শুভম, স্টার্ট করেছো পড়াশোনা? ফেল করলে কি হবে? আচ্ছা, এই অন্বেষা, আমি ইন্ডেক্সিং শুধু করিয়েছিলাম, হ্যাশিং কি করিয়েছিলাম? শুধু ইন্ডেক্সিং হয়েছিল না? শুভম, জানো ইন্ডেক্সিং? জয়শ্রী, করেছো ইন্ডেক্সিং? শুভম, ইন্ডেক্সিং করেছিলে বিসিএতে? কিছু আছে, মনে আছে? ঠিক আছে, আমি ইন্ডেক্সিং আজকে একবার রিপিট করছি, অ্যান্ড হ্যাশিংটা তার সাথে করাচ্ছি। হ্যাশিং এর জাস্ট অনলি কনসেপ্ট ইউ হ্যাভ। Okay. What is the main goal of designing a database? Hello. Bolo. What is the main goal of designing a database? Yeah, means ঠিক আছে, means uh, you can access the data very easily, right? The main goal of the designing the database is what? That number one is that quicker access of the data, and also um, quickly you can insert or delete or update the data, right? So this is the advantage of using the database, and we are familiar with the relational database. আমরা যেটা করি by Oracle or by MySQL, whatever. This is the relational database where the data are stored in the form of table, right? And why? That's the same thing, means when you are browsing something in internet through the web browser, this is also the transfer of the data from one database to your end, right? And when a database is very huge, so at that time, even a smallest transaction is taking also is taking time to perform some actions, right? Means if your database is very huge and it is taking a time, means it is getting slower, right? So now when you are doing the transaction, means in order to reduce the time spent in transaction, these indexes are used. Like if you take the example of a book. Suppose if you take the example of a book and you want suppose you want to search for a topic like that, shadow paging, right? So you have that book of that Dbms book of Korth, right? This is it's a very huge book, right? Because it has 1500 or 1600 pages, right? So it's a very huge book, and you want a topic that shadow paging. So it is difficult to search in every pages, right? So what we do, we are going to the index, right? We are going to the index, and in index what we have seen, the the topic name and the page number, right? It is written in the index, isn't it? তাই লেখা থাকে তো আমাদের index যদি দেখি, বা or you can go to the catalog also. So in the catalog also it is also written that this is the topic name and the page number, so you can easily find that topic, right? Means it makes our search simpler and quicker also. So the same concept is applied here in Dbms to access the files from the memory, right? And if you consider about the memory hierarchy, so we know that the primary memory is faster than the secondary memory. Means if you consider the memory hierarchy, so RAM, ROM, RAM is the first. RAM is faster than the secondary memory, right? But at the same time, RAM is volatile memory. Means if anything is stored inside the RAM, and if failures occur, or your system getting restarted, then everything what is stored inside the RAM all are deleted, right? But still accessing something from RAM is very easy and quick. But if the number of record stored in the database is very huge, and also the size of the RAM is limited, right? That size of the RAM is what? This is limited, because this RAM is not only used to store the data in the database, but this RAM is working for other works in your system, right? So if the number of records are very huge, now suppose you are dealing with the database of a company, a multinational company, so if the number of records are very huge, then it is, you need to store the data in the secondary hard disk or the secondary memory, right? Like hard disk, isn't it? Right. Second thing, as we are familiar with the relational database, that we are storing the data in the form of a table, and we are also we can see also that the data is stored in the form of a table, but actually it is not stored like that in the memory, isn't it? Then আমরা যেভাবে দেখছি ট্যাবুলার ফর্মে স্টোর হচ্ছে বা কিছু, দিস ইজ দ্য লজিক্যাল ভিউ, রাইট? বাট ফিজিক্যাল ভিউতে তো physically তো it is not storing like that. It is storing the different blocks of the memory. It is storing in the different blocks of the memory. They are stored in the form of a file in different data blocks. And this block is capable of storing one or more records depending on its size. ঠিক আছে? So when we have to retrieve any required data, or if you want to perform some transaction on those data, so you need to pull the data from the memory, and then you need to do the you need to perform the transaction, তাই তো নাকি? Normal transaction যেভাবে হয় যে, so you need to pull all the data from the memory, and you are doing some transaction, and again you are saving the data back to the memory. So to complete all these activities, or to perform all these activities, so we need to have a link between the records and the data blocks, right? You need to link between the records and the data blocks so that you can know where these records are stored, right? And this link between the record and the data block where the records are stored is called index. ठीक है sir? So the link between the records and the data blocks where the records are stored is called the index. So you can say that this index is like a bridge between the records and the data blocks. ठीक है sir? बाकीদের
প্যান কার্ডের নাম্বার আছে আমাদের ফটো
Okay, so we are going to next. We know that when the table means in logical view, we have seen that the data is stored in the form of a table and each table has a unique column, right, or unique attribute which is known as the key attribute, isn't it? So now question is that how we can create the index. Then আমাদের তো আমরা বললাম the index is what, this is the link between the records and the data blocks and etc etc. So now how do we create that indexes, right? So this is important, and how also that indexes help us to access the data properly. Hmm. And that we do in two ways. One, by using the primary key of the table, right? Means we can create the index based on the primary key, but sometimes it is also important to fetch the data which are associated with the non-key attributes also. তাই না, সবসময় যে কি অ্যাট্রিবিউটেড ডেটা আমরা অ্যাক্সেস করি তা তো নয়, সামটাইম উই অলসো require the other data also which are associated with the non-key attributes, right? So in that cases also we create the index on that non-prime attributes also, right? But in general the index is what, it is actually acting as a pointer. I told you that it is linking, it is acting as a link between the records and the uh, data block. And if you remember about the concept of the pointer, it is also doing the same thing. So index is what, it is a pointer to the block address in the memory, right? So what is index? Index is what, a pointer okay. And what is the format of that pointer? Column name, and blog address. Okay. ঠিক আছে বাকিরা বুঝতে পারছো
हाँ सर
ওকে শুভম বুঝতে পারছো শুভম আছো তো নাকি okay so now this indexes are of so what are the different types of the indexing so this is ordered indices clustering indices and secondary indices okay and these primary indices also are of two types that one is the dense one and another one is the sparse one okay so what is ordered indices মনে আছে অন্বেষা what is ordered indices কি হলো ordered indices suppose I have a table suppose I have an employee table okay I have a employee table with the attributes like employee ID, EMP name, like department, or suppose DOB, department, and etc. Whatever. Okay. So, and that table has very huge records, like suppose thousands or 10,000 records, and each record is of and the length of each record is what? This is 10 bytes long. Okay. So obviously, suppose the ID is started like E1, E2, E3, dot 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 like that. Okay, suppose the ID is like that, that E001, E002, E003. So like that. Clear? Now suppose I want to search ID like that. Okay. Suppose I want to search a record against this ID. So if you're in your database, so if there is no index, if there is no index in the database, like suppose ধরো তোমার বইতে কোনো ইন্ডেক্সিং নেই, তুমি শ্যাডো পেজিং খুঁজছো, তো তুমি কি করবে? তুমি প্রত্যেকটা পেজ খুঁজতে 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 যাবে, রাইট? তাই তো? So if you want to find the record against this E456, so you can find the record, or yes, you can find the record after this bytes. Simple calculation. আর তোমাকে প্রত্যেকটা রেকর্ড খুঁজে 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 আসতে হবে, তাই তো? Okay. Now if you have the index, now if you have index, so the index, what is the format of the index? This is the column name and the block address. So and here we have created the index on the primary key, on ID. We have created the index on the employee ID, right? So if you have, so if you have the index, then the address of each record it will be like that, E001 comma, suppose it is stored at like that, E002. And so on, like that. Means, so you can think that it is a table where the first column is the that index column, the index on which the column on which the index has been done, and the second column is what? This is the data block address, right? Now if you want to search the record against this E456, then what? So how many byte it will trace? কত? এখন আমি চাইছি যে এটা করতে। নাও আই ওয়ান্ট টু ফাইন্ড দ্য রেকর্ড অফ দিস স্টুডেন্ট ইউজিং ইন্ডেক্স। তাহলে কতটা বাইট ট্রাভার্স করবে? সেটা তো যখন ইন্ডেক্সিং ছিল না তখন। এখন তো আমার ইন্ডেক্সিং আছে। সোহাম, কত হবে শুভম? হুম, কতটা যেতে হবে? হ্যালো, এখানে মাঝখানে গ্যাপ আছে, 3 4 5 6 করে যাবে ওটা। ও আগের ইন্ডেক্সিং থেকে স্টার্ট করবে না? না, হ্যাঁ, তো আমার সেটাই এখন যদি যদি আমাকে যদি 455 4 5 6 এই স্টুডেন্টের রেকর্ড যদি আমাকে যদি ট্রেস করতে হয়, তাহলে কতটা বাইট ট্রাভার্স করতে হবে, মানে কতটা তোমাকে খুঁজতে হবে। This is 455 into 2. So this is 910 bytes only, which is very less compared to the previous one. তাই না? বলো কেন হলো? তুমি বলো, ভেবে বলো। বাকিরা কিছু বলবে? শুভম, জয়শ্রী,
না স্যার, বুঝতে পারছি না।
শুভম, আচ্ছা, এবার ধরো তোমার ইন্ডেক্সিং করা আছে, ঠিক আছে? তুমি তো একটা বইয়ের কথা ভাবো, তো তোমাকে বলে দেওয়া হলো যে তুমি 456, ধরো তুমি 456 পেজে কিছু খুঁজতে চাইছো, লাইক দ্যাট। আচ্ছা, তো তুমি নিশ্চয়ই, আচ্ছা তুমি যদি স্টার্ট করো তোমার মানে সার্চিং কোনো পার্টিকুলার টপিক, তো সেটা নিশ্চয়ই 456 পেজ থেকেই শুরু করবে, তাই তো? আচ্ছা, বা এটাও হতে পারে যে তুমি তার আগের পেজ থেকে শুরু করছো, রাইট? যে 455, কারণ 455 পর্যন্ত কিছু নেই আমি জানি। তো আমাকে যখন বলছে যে ইউ হ্যাভ টু ফাইন্ড দ্য রেকর্ড এগেনস্ট দ্য 456 স্টুডেন্ট, তো আমার এখানে যেটা আছে সেটা হচ্ছে আমি 455 থেকে আমি সার্চিংটা স্টার্ট করছি। আমাকে কিন্তু কোনো রেকর্ড এখানে ট্রেস করতে হচ্ছে না, আর প্রত্যেকটা রেকর্ড হচ্ছে তোমার 10 বাইটস লং বলা আছে, তাই না? আমাকে প্রত্যেকটা রেকর্ড তো আমাকে ট্রেস করতে হচ্ছে না, শুধু হচ্ছে আমার অ্যাট্রিবিউট, যে মানে লোকেশনটা জাস্ট চেঞ্জ করতে হচ্ছে, রাইট? আমাকে লোকেশনগুলো শুধু চেঞ্জ করতে হচ্ছে, যে 455-এ ছিল সেখান থেকে তোমার 456। আচ্ছা, ইন্টিজারের সাইজ কত? জেনারেলি 2 বাইটস থেকে স্টার্ট হয়, তাই তো? ওই জন্য হচ্ছে আমাকে এই যে 455 × 2 মানে অ্যাটলিস্ট 2 বাইটস আমাকে সার্চ করতে হচ্ছে, কারণ যেহেতু আমার 455 থেকে 456-এ যাচ্ছে। বোঝাতে পারলাম? ঠিক আছে? এবার তোমার সিস্টেম যদি মানে 4 বাইটস ইন্টিজার বা তোমার সিস্টেম যদি 64 বিট হয় বা 32, জেনারেলি এখন সবই 32 বিট 64 বিট, তো এখন জেনারেলি 4 বাইট করেই নেয়। তখন আবার এই সাইজটা বেড়ে যাবে আর কি, 10 বাইটস হবে না। তো যদি আমি ধরে নিই এটা 4 বাইটস যদি ধরে নিই, তো ইট ইজ ভেরি লেস কম্পেয়ার টু দিস। আমি যদি ধরে নিই যে তোমার সিস্টেম ইন্টিজার জন্য তোমার 2 বাইটস, আমি যদি বেসিক্যালি তো ভ্যারকার 2 হয় এখানে, তাই না? তো ভ্যারকার 2 এর সাইজ কত? আমি একেবারে ডিরেক্টলি যদি আমি এসকিউএল এর কনসেপ্টেই যদি আসি, ভ্যারকার 2 এর সাইজ কত? 16,
ওয়ান।
ভ্যারকার 2 যদি নিই তো ভ্যারকার 2 জেনারেলি আমার 2 বাইট করে নেয়। আমরা যদি ডিরেক্টলি
ওয়ান ভ্যারকার শুধু তো 1 বাইট।
যদি 0 থেকে 255 মানে শুধু ভ্যারকার বলিনি, ভ্যারকার 2 বলেছি।
আচ্ছা, তাহলে 2 বাইট।
আমরা তো ভ্যারকার 2 নিয়েই নিই, তাই না? যদি আমরা ডিরেক্টলি যদি ওরাকেলের যদি কনসেপ্টটা যদি অ্যাপ্লাই করি আমরা সিকুয়েলে, তো সেখানে যদি 2 বাইট নেয় প্রত্যেকটা কলাম, তো দেখতেই পাচ্ছি দিস ইজ টেকিং অনলি দিস 2 বাইট মিনস 910। তো ইট ইজ ভেরি লেস কম্পেয়ার টু দিস, তাই না? সো দ্যাটস ওয়াই আমরা কি বলতে পারি যে ইফ ইউ ইউজ দ্য ইন্ডেক্সিং, তো it is fast or it is easier to access the particular data, তাই না? But you need to remember one thing, that it is only possible if your data is arranged either in ascending or in descending order, means your data are sorted, তাই না? এখানে that employee ID I have arranged in ascending order, that 1 2 3 E001 E002 E003 and so on. That's why your index are sorted, তাই না? So so that's why it is known as the ordered indices. Ordered indices means what? That the column on which you are creating the index, that column should be sorted. Is it clear? সর্টেড না হলে তো এইভাবে আমি ট্রেস করতে পারতাম না। ঠিক আছে বাকিদের? So next one is what? This is the primary index, primary indices. It is what? That if the index is created on the primary key, if the index is created on the primary key, then it is known as the primary indexing. ঠিক আছে? And this primary key, primary indexes are of two types. There's a dense one and the sparse one, right? So now what is the dense index? If the indexing is created on the primary key and as well as on the columns on which we perform the transactions. ठीक है? So dense means what? That means suppose if your indexing is created on the primary key attribute as well as on non-prime attribute, then it is known as the dense index. ठीक है? Means you can generate the query based on any columns in the table according to your requirement. ठीक है? So here you can see that example. So you can search the data based on the student ID that you can search, right? Because this data is unique, isn't it? In addition to this student ID, you can search by his first name also, or by his name also, that 100 Joseph or 105 Jessica, like that, isn't it? You can find the student with age group also, isn't it? Parito. Or you can find the student with ID as well as with address also. মানে আইডিটাও থাকছে, but with that you are adding the extra attribute which is not the key attribute to find a particular record. ঠিক আছে? আমি বললাম যে suppose find the student whose ID is 105 and who is residing at Clinton Township. তার মানে আমরা এখানে দুটো কনস্ট্রেন্ট অ্যাপ্লাই করছি, তাই না? একটা হচ্ছে আইডি আর একটা হচ্ছে অ্যাড্রেস, রাইট? But the ID is the primary index, but the address is not the primary index, not the primary column. Is it clear? আমরা করি তো, কোয়ারি জেনারেট করি তো এভাবে। বোঝা যাচ্ছে? বাকিরা বুঝতে পারছো? So suppose find the age of the student whose ID is 105 and who is residing at Clinton Township, like that. So means we are creating the index on two columns, where one column is the primary column and another one is the non-prime column. ঠিক আছে? But one problem is there. The space. Now the question is the space-time complexity. That is the main concern, right? Na? Space-time complexity is the main concern, whatever you are doing. Right? So here the space used for this dense index and the corresponding address becomes overhead in the memory. Can? Because here all the columns are acting as an indexes, as acting as an indices. তাই না? ID তো ছিলই, তার সাথে you can add name, you can add address, you can add age, you can add course, তাই না? তার মানে আমাদের যে ম্যাপিং যেটা ছিল, that index address, that format, right? This is equivalent to key table record comma address, তাই তো সবকটাই তো নিচ্ছি আমরা, তাই না? আমরা সবকটা অ্যাট্রিবিউটকে তো কনসিডার করছি। So hence more space is consumed to store the indexes. Obviously রেকর্ডের সাইজ যত বাড়বে তত আবার বেশি স্পেস লাগবে। This is one of the drawback of the dense index. ঠিক আছে, বাকিটা বুঝতে পেরেছো? হ্যালো, so next one is the sparse index. So to overcome the issue, what occurs in dense indexing, that's the space issue, right? So that can be achieved or can be removed by the sparse indexing. And how to solve that? In this method, a range of index columns store the same data block address. So here you can see that we have the range of columns, index columns, right? And when the data is to be retrieved, the block address are fetched linearly till we get the requested data. Suppose I want to find the record of 104, ঠিক আছে? তো এখানে দেখতে পাচ্ছি যে I have the data regarding 102 to 108, তাই তো আমার total not a data, I have the record of 9 students, but I have created only the index for 3 students, তাই তো নাকি? 100, 103 and 106. Means we have not stored the indexes for all the records. So now if you want to search the details of Jack, means the details of the student with ID 104, তাহলে আমরা কোথায় যাব? First we will search in this table that the ID which is less than or equal to the ID in the index table. So less than or equal to হলে কে হবে? This is 103, right? তো এই ডেটার এগেইনস্টে যাবে, it will search here, তাই তো? এখান থেকে searching start হবে, then it will linearly search that 103, then 104, like that. That's why in sparse index the data blocks are fetched linearly till we get the requested data. Right? So it makes the searching faster and also reduces the storage space. isn't it? And the range of columns, that one, the range of columns can be vary depending on the number of records. Okay. But one drawback is there. What is the drawback? If the number of records are very huge, and if you create a large range, ठीक है sir? Then this sparse index, that method will not work. Means when, if you want to use the sparse index, then the column range uh, uh, should be shorter. If you don't do this, then it will be uh, it will take the same space like the dense indexing. What's the love? Next is the what? This is a secondary index. What is secondary index? So what are the drawback? What is the drawback of the sparse index? That if the table size grows, right, means if the number of records grows, so obviously that index uh, address mapping, that file size will also grow, isn't it? So in the memory, so obviously this mapping are kept in the primary memory. And the mapping যেটা হয়, so this is kept in the primary memory, right? So that we can fetch the record very easily. তাই তো? Hmm?
हाँ
And the actual data, is searched from the secondary memory based on the address got from that mapping. And if the size of this mapping grows, the fetching address itself becomes lower. And in that case, the sparse index will not be efficient. So that's why we are using the secondary index. Here, the another level of indexing is introduced to reduce that index address mapping size. Right. Here, initially, a huge range of columns are selected. Here you can see this is 100, 200, 300. So, a huge range of columns. Right. These are selected so that the first level of mapping is small. So, here you can see that I have 300 records and I have mapped only 3 records, 100, 200 and 300, and the range is very huge that you can see. Now, this each range is further divided into the smaller range. Here you can see that it is divided into small ranges. This one, that 100, this is 10, the range is 10, 100 to 110, 109, 110 to 119, then 122, like that. So here each range is further divided into smaller ranges, right? So here you can see the two levels of mappings are there. And this first level of mapping is stored in the primary memory, and this one is stored in the secondary memory. So now if you want to search a record against any ID, so it will first search on the primary memory, then it will sequentially search in the secondary. Suppose you want to uh, find the record regarding 1 to 1, right? So first it will search which is less than of this 1 to 1, so it will start the searching from here, then it will come here, and here also it will sequentially search, isn't it? So it will come to this section 120, then it will come to this. Is it clear? Next one is what? This is a clustering index. So till now we are talking about the indexing on primary key, right? This is the primary index and etc. So now sometime it is required to create the indexing on the non-prime key also, and we know that that uh, that that uh, that may not be unique for each record, non-prime. So in such cases, in order to identify the records faster, we group, we are making group 2 or more columns together to get the unique value and created the index out of them. কি বললাম বোঝা গেল? If you want to, in clustering index কি হয় না, we are creating the index on the non prime attributes or non, ঠিক আছে? So now when you are creating the index on this non prime attributes or non primary key attributes, so at that point you need to make group of such columns, 2 or more columns, so that you can uniquely identify each record. So here the records with similar characteristics are grouped together and indexes are created for these groups. So now you can see that suppose the semester that we have grouped that we are making the group semester wise, that the students who are studying in first semester, or student who are studying in second semester, student who are studying in third semester, and so on, like that, right? So in the data block, students of each semester are grouped together to form the cluster. The address in the index file points to the beginning of each cluster, this one. And if you want to insert any data, suppose a new record should be you want to insert a new record into that cluster, and suppose if a new student join in the fourth semester, right, so that you can easily do this from here, and similarly you can update or you can delete the data, right? And one question can arise that if there is the short of memory in any cluster, যদি কোনো মেমোরি শর্টেজ হয়, হতেই পারে যে স্টুডেন্ট বাড়ছে, so you can add a new data block to the cluster also. Here you can see that a new data block has been with that. So this method so this method of file organization is better compared to other methods, because it provides a clean distribution of the records, and also it is making the searching easier and faster. একটাই problem that there can be unused space left in the clustering, and obviously it is taking more memory to store the indexing. ঠিক আছে? So this is the comparison of this indexing. Any question? You have the concept of the hashing only, means it is not actually. So next is hashing, means the concept only. হ্যাশিংটা একটু টাইম লাগবে। হ্যাশিং তো তোমাদের হ্যাশিং মনে আছে কিছু? Hashing is nothing but means if you have the group of objects, right, and if you want to find, means if you uniquely identify a specific object from that group of object, then that you can say this is the hashing. Like ধরো তোমাদের এই যে all of you have the unique roll number in Macaut, right? Means if I put the roll number of you, if I put the roll number of any student, so I can get the data, right? So that hash function means by using that primary key, we are using generating the hash index. Means that by using that hash function, we are generating the address of the each data block, and obviously here we are taking the help of the primary key to create that hash index. So that hash file organization method is one where the data is stored at the data blocks whose address is generated by using the hash function. And এই hash functionটা কি করে? It is taking the primary key column to generate that address, right? The memory location where these records are stored, it is called the data block, the data buckets. So here the primary key itself considered as the address of the data block. And each row is stored at that data blocks whose address is same as the address of the primary key. This is the concept of the hashing. Here you can say that this is the primary key, right? This is the primary key, and the hashing is the hash function has generated the address on this primary key. Means the hash function has created the hash index similar to that address of the primary key, the 98.103.106.104 like that. And you can easily find the data in the memory. Now this is the data block. Here you can see that the data block address same as the primary key value, and this hash function can also be simple mathematical functions like mod, sine, cos, exponential, etc. That you can see. ঠিক আছে? Any question? ঠিক আছে, তাহলে এই পর্যন্ত থাক আজকে। ওকে।